Hi friends, a very good evening to all of you. I hope you've had a wonderful Dashera. To end the wonderful occasion, festive occasion, we are going to have the crash course for 2023 CAT. Sorry. So today we're going to start off with something called as algebra. We're going to take up what happened in algebra over the last few years. I'm going to take you through the importance of this topic with respect to the number of questions. I'm also going to take you through which topics have appeared the most and what type of questions have come. The session today is also going to be a kind of a revision for you with respect to the formulae. We're going to go through certain basic formulae, certain basic ideas, and then once these are in place, we are going to go ahead and solve few questions. So today, think of it as a revision of algebra, right? So we are looking at getting 20. The target of the session today is to get around 20 plus marks as score in your algebra topic. Okay. Now, why 20 plus, which means you're looking at 6 minimum, 6, not even 6. In fact, you're getting 7 questions from algebra. That's the expectation. Now, I'll take you through, is it realistic or not? What happened in the last few years? So I have an analysis for this. So let's begin by understanding how important is algebra and what happened in it over the last few years. Okay, so let's move on. By the way, I have my phone over here. Basically, I'm using it to look at your chat. So I'll keep peeping into it once in a while, so don't mind. Let's go ahead and take a look at what is the weightage of CAT in this particular weightage of this particular topic in CAT. So the topic obviously is coming under quantitative aptitude. No wonder. The area is algebra we're going to talk about. Now the weightage is a very important part. This is the second biggest topic and a close second, not even a distant second. It's a close second topic for you. First, the most important topic is arithmetic. Okay, this definitely is number one, no doubt. But very close to this is algebra. Now, how important is this? Look at this. We are expecting 30 to 35% of the paper. Guys, that is huge. You're talking about 22 questions and 30%. 30% of 22 is 6.6. So basically you're talking about 6 to 7 questions from algebra minimum. Minimum is expectation. Let's see, is this expectation too much or too less? What happened actually in the last few years? So I have my team put together a table which will explain to you what actually happened in the CAT papers over the last few years for the topic called algebra. So let's not go by what I say, let's see what the data says, right? So here we are, topics that are coming under algebra: surds and indices, equations, all types of equations, linear, quadratic, inequalities, special equations. Then we have functions and graphs. Then we have logarithms. Then we have progressions. And of course, we have modulus, maxima and minima. These are the various topics that come under your heading of algebra. Okay. A very good evening, Gaurav Kumar. Anyway, so let's move on. So what is the trend over the last 5 years? So if you notice, these are the 3 slots last year. These are the 3 slots the year before. And these are the 3 slots the peak of the COVID. And now these are 2 slots before COVID. And these are 2 slots pre-COVID. Now remember, these had 34 questions total. 34 questions total. Now 20, I believe, had 24 questions, 26 questions in Quant. 26 questions in Quant. And 2021 and 2022, this had 22 questions and 22 questions in each paper. This is for you. For those of you who don't know, this is how the papers were. Let's take a look at what happened in each year. In 19 and 18, out of 34 questions, this was a 1 hour paper. 1 hour paper. This was 40 minutes. This was also 40 minutes. This was 40 minutes. Section only for Quant. Okay. Only Quant section, 19 and 18, 1 hour. 20, 21, 22, 40 minutes. Now you can see 9, 7 and 8. You're talking about 7 to 9 questions out of 34. 7 to 9 questions out of 34, right? So that's what percentage approximately? 7 4s are 28, 7 5s are 35. So you're talking about 20% weightage, 20 to 25% weightage, right? 20 to 25% weightage, that's the approximate value. Now let's look at what happened in 2020. Out of 26, while the total questions have come down, the algebra did not change by that much. You can see 10 questions were in one paper because they were morning, afternoon and evening slots. So forenoon, noon and afternoon, evening slots. So you had 6, 10 and 6. And more importantly, when you come to this format of 22 questions in 40 minutes, which has been constant for 2 years, the very important part for you to realize is the number of questions have come down further. But the number of questions here from algebra did not change much. Please look at it. You are looking at 7 to 9 questions, or rather 6 to 9 questions. So this 7 to 9 is still the same, but now out of only 22. So you're easily, very easily, you're talking about 33% weightage. So the weightage for algebra has gone up drastically. The weightage for algebra has gone up drastically compared to pre-COVID years. Today, it's that's what we said, 30 to 35, easily going towards 35 is what we observed last year. So almost 35% weightage will be from here, and arithmetic will be around 9-10 questions. So that would be 10 out of 12. So about 40-45% weightage. So these two topics together will give you 80%. It's not a small number, guys. It is not a small number. So 80% you're talking about from two topics. That is 9 to 10 questions arithmetic and 7 to 9 questions algebra. You are minimum looking at 16 to 19 questions from this. Many people wonder, sir, what should I study? I'm weak in maths. Boss, it is not that you're weak in maths. You need patience to prepare two topics only. You don't like geometry, throw it out. You don't like permutation combination, throw it out. Nobody bothers, nobody cares. You don't like number theory, throw it out. You don't care. Doesn't really matter. This is what matters. And this is enough for you to get into the 99 percentile range very easily. Because in Quant, a good student in Quant will be looking at a 90% accuracy. So you attempt 17 questions, make 2 mistakes, 15 corrects, 2 wrong. You're talking about 43 marks. Done. You are going to be in that 99 point percentile in Quant. So your strategy should be to make sure that arithmetic and algebra are not lost. Anyway, today we're going to talk about algebra. But before we go ahead, okay, I've got Gaurav Kumar's statement which says FNG seems very difficult and does not seem to give return on investment. Gaurav, functions and graphs. Functions and graphs is not really difficult. There are certain types of questions that come in functions and graphs. If you are familiar with those type of questions, it becomes very easy. Guys, remember, all those of you who are afraid of algebra, I'll give you an analogy with language. When you listen to a language for the first time, you will not know anything. Some of you might be following Japanese anime, some of you might be following Chinese serials or Korean serials. Lately, it's the fad. Remember, first anime or first Korean serial that you have seen, did you understand a bit of any word? Everything is gibberish. You can't make sense out of it. You need subtitles. But slowly as you keep watching, some terms will start becoming familiar. Okay, in Japanese, when you start listening more and more to the dialogues, you'll start realizing, oh, this word means this. This word, you will not be able to form the entire sentence. That's okay. But you will start finding things familiar. The more you watch, the more the familiarity begins or grows. And slowly after a point in time, you will start realizing that, okay, it's not a completely different language. I can make sense out of it. At least some basic things are sensible to me. I can understand them. That is what happens in your algebra also. First time when you look, if you are not from the maths background, you're weak or you're afraid of it, you look at algebra for the first time, you're like, oh, I can't do this. It's too difficult. But then slowly, When you keep spending more and more time, see, if you stop doing it, it'll always be new to you. But you have to go past that fear. Push yourself to spend time with it. And slowly you will start seeing those small points like in the language. And then over a period of time, you'll start realizing that, hey, this is not Greek and Latin. It's something that I can understand now. Right? So keep this analogy in mind, my friends. If you are afraid and you say something is not at all possible, it's only because you're not spending enough time. But let's move on. Kush Patel says, sir, slowly I'm getting to improve in quant and able to solve cat level questions. But as of now, exam is coming here. I want gear. What should I do now? Kush, don't worry about learning too many topics. As I said, are you good in arithmetic first? If you are not perfect in arithmetic, spend time only on arithmetic. If you've gotten good in arithmetic, then you move to algebra. Don't think of too many things. Keep it very simple. One thing at a time. Perfect arithmetic. If arithmetic is perfected, then go to algebra. In algebra also not huge. Algebra first take up all types of equation questions. Simple equations, linear and special equations, quadratic equations, polynomials. Polynomials you can leave. Till quadratic equations you solve. Are you perfect in this? If you become perfect in this, then go to the next step. Probably you can take up logarithms. But take one thing at a time. Don't say that I have so many things to finish. No, that's not the way to look at it. You know you're weak in math, so your step will be to perfect each small quantity. It's okay. If you can't prepare 50% of maths, doesn't matter. The other 50% did you prepare well? Even if you prepare 40%, did you prepare well? That's my question. If you have done it good enough, you will easily get, because you're weak in maths, you don't expect a 99 percentile. So can you get a 90 percentile? Easily. Easily you can get a 90 percentile. Only arithmetic is enough for that. But let's move ahead. Alright, so some important formulae very quickly to go ahead and take a look at the questions later on. Basic algebraic formulae. I'm sure you guys know all of this. A plus b the whole square, a minus b the whole square. I'm not getting into the basic part of this. This is very much known to all of you. So a plus b the whole cube, you might not use it that often, but it makes sense to remember. A cube plus 3a square b. This can also be remembered as a cube plus 3ab into a plus b cube, and this can be remembered as a cube plus 3ab minus 3ab into a minus b cube. Okay, you can remember it this way. And then you have a cube plus b cube, and then you have a cube minus b cube, then you have a square minus b square. These are basic formulae which we will use time and again in algebra. A lot of questions have come on this type. Okay. Continuation of it, we have again a square plus b square plus a square minus b square is basically your 2ab gets cancelled, plus 2ab minus 2ab gets cancelled, so you'll be left out only with the perfect squares. Then you have the reverse of it when you subtract. So these you don't have to by heart, not required. Till here, if you by heart, in my opinion, if you by heart these, that is good. Formula 8 and 9 are just extensions. You don't have to remember them, because if you know the 7 perfectly, 8 and 9 are just a derivation of them. Leave it. This is important. 10th is something important. Please remember that. And 11th is also important. Okay. Now, please remember 10th and 11th, you don't use it very often, but there are questions that are designed where you are going to, the specific questions which are made where they force you to use this. Without this, you can't get an answer. Such a question, if you are good in algebra, you should know this formula and get the answer. It is not going to be very difficult. Okay. So a plus b plus c the whole square is a square plus b square plus 2ab plus 2bc plus 2ca. So you can remember it as a square plus b square plus c square plus 2 times cyclical order ab plus bc plus ca. Okay. Then a cube plus b cube plus c cube minus 3abc is a plus b plus c into a square plus b square plus c square minus of the cyclical order ab bc ca. Okay. Now the only thing you need to keep in mind is if a plus b plus c is 0, then this right hand side becomes completely 0. Then what happens? If a plus b plus c is 0, then only left hand side and right hand side is 0. So you get a cube plus b cube plus c cube is equal to 3abc. And the corollary is also vice versa is also true. If this is true, then it also means that a plus b plus c is 0. Both, if a plus b plus 0, then this is true. If this is true, then a plus b plus c is 0. Right? So these are the basic formulae as far as your basic algebra is concerned. Okay. Kota Harish, formula remembering is the hardest part. It will be hard if you read it like a book. Did you write twice a day for 10 days? You write it twice a day or 5 times a day like a kid when they write. You know, when I was a kid, my school teachers for various subjects used to give us an imposition. Write this 5 times. Write this 10 times. When you write, you will not forget. If you read, you will forget easily. And not once. Today you write 5 times. Tomorrow you write 5 times. Day after tomorrow you write 5 times. Do it for 15 days. Over. It will not go out of your mind. And it will, how long do you think it will take you? It will take you probably 5 minutes, 10 minutes to write. 10 minutes of your time for 10 days or 15 days. You will never ever forget. It's not a big investment at all. It's easy. Okay? Well, let's move on. Now we have few basic formulae for linear equations. If there are two equations, a1x plus b1y plus c1 equal to 0 and this is 2x plus b2x plus c2 equal to 0, then the unique solution exists. Unique solution means you are able to solve for x and y and get one value of x. You'll get one value of x and one value of y, like x1 and y1. You'll get a proper value of x and a proper value of y. If and only if a1 by a2 is not equal to b1 by b2. The logic behind is, if this is true, then these two lines, at the end of the day, remember, an equation in x and y is a straight line, correct? It is a straight line. So, two straight lines, if they intersect, you will have one point of meeting. That is your answer. If they are parallel, if they are two parallel lines, they will never meet. There is no answer. So, when the two ratios are not equal, it means you are talking about intersecting lines. Intersecting lines means a1 by a2 ratio is not equal to b1 by b2 ratio. If they are equal, it means the two equations represent a pair of parallel lines, and parallel lines do not intersect. Clear? Which means, so it's like asking, when do the two parallel lines meet? They never meet. There's no solution. That is the meaning. And the third thing is, if a1 by a2 is equal to b1 by b2, which is also equal to c1 by c2, then what does it mean? If this is happening, then it is not just, so here remember, this is not equal to c1 by c2. So a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. Then the lines are called parallel. But if all three ratios are same, then what does it mean? It means you have a line, on top of it you have another line. Basically you're talking about the same line. On top of it you have another line. So if I ask you how many points do they intersect, there are infinite points of meeting, right? Because every point is a point of intersection, because there are two lines that are coinciding on top of each other. So which means there are infinite solutions. So if you have a1 by a2 equal to b1 by b2 equal to c1 by c2, it means there are infinite points. So if you understand this with respect to the logic of lines, then remembering this becomes very, very easy for you. Parallel lines, no answer. Coincident lines, infinite answers. Intersecting lines, one answer. What is the condition? These are the conditions. Simple, right? Let's move on. Okay, believer says, sir, अब तक geometry नहीं किया है, only arithmetic and algebra किया तो चलेगा या अब geometry भी करे? If you have not done geometry, stick to arithmetic and algebra. This is not the time to start geometry for you. Please become perfect in arithmetic and algebra. I already explained to you, if you become perfect in these two, 16 questions are in your hand. Minimum 16 questions are in your hand. That is more than enough in your 40 minutes. That is more than enough in your 40 minutes. You will go for a geometry if your target is to reach a 99.6, 99.7 percentile. Which means the arithmetic and algebra, out of 15-16 questions, you should be getting 14-15 corrects. Only then you think about geometry, right? But if you are not reached that state where all 15-16 you are attempting in arithmetic and algebra, and you are making mistakes, you are making silly errors, you are slow, then geometry will not help you. It's better that you spend more time on arithmetic and algebra and become perfect in it. But if you are already out of 15, 16 arithmetic plus algebra, if you are already able to solve something like 14, then it is time for you to go for a third topic called geometry. Right? Simple? Believer? Sir, it's lagging in app. Virendra Singh. All right. बिलीवर सेज सर यूट्यूबर्स बोलते हैं कि ज्योमेट्री भी करो नंबर सिस्टम भी करो वरना कैट नहीं होगा। भाई मुझे नहीं पता कि कौन क्या बोल रहा है। मैं पढ़ चुका हूँ, कैट क्रैक कर चुका हूँ। आई एम इंदौर जा चुका हूँ। व्हेन आई वेंट इन आई गॉट अ 99.7 percentile. My quant percentile was 99.8. My overall percentile was 99.7. Last year I wrote CAT again. I got a 99.6 overall and a 99.8 in quant. I'm telling you, you don't have to worry about geometry if you are perfecting arithmetic and algebra. If you are not perfected arithmetic and algebra, geometry, I mean, there's no point, right? You are not perfect in this. There also it will be half baked. Nothing will be coming your way. Spend your time, make sure that your arithmetic and algebra, when I say perfect, out of 15, 16 questions, 14 questions or 13 at least you should be able to attempt. That is the meaning of perfect. Okay? Let's move on. Alright, so we have few more formulae in quadratic equations. Roots of a quadratic equation. First of all, quadratic expression. A quadratic expression is ax square plus bx plus c. A quadratic equation is ax square plus bx plus c equal to 0. So this is called as an expression, this is called as an equation, right? When there's an equal to, it's an equation, otherwise it is an expression. When there's no equal to, it's just an expression. Now, the roots will be existing for an equation, not for an expression. Roots always exist for an equation. So the roots of this equation is given by this formula, which you all know, minus b plus or minus root of b square minus 4ac under root by 2a. Okay. Okay, I've got a couple of believer says, okay sir, only arithmetic and algebra hi karunga. Good, nice. Sunny Joseph says, sir, for DILR we need concepts of modern math and number system. No, DILR doesn't need modern math and number system. Don't worry. For DILR, you don't need number system and modern math. Those kind of questions don't come in your DILR. Please leave it out. Next, Kush Patel says, means you are my dream college alumni. I'll be your super alumni. I've gone to it almost 13 years, 14 years back. So yeah, I hope you are my super junior too, right? Wishing you all the best to that. But let's move on. Now, formation of an equation if the roots are given. Now, the questions sometimes come like this. If there are two roots to an equation which are alpha and beta, there are two roots saying that, okay, alpha and beta are two roots, find the equation. It is given by x square minus alpha plus beta times x plus alpha beta equal to 0. So the equation, the quadratic equation, when two roots are known, is given by this formula, x square minus of alpha plus beta times x plus alpha beta equal to 0. Okay. Gaurav says percentage use hoga DI mein. Yes, Gaurav, percentages are used. Arithmetic is used in your DI. So please don't leave arithmetic. That's why I said arithmetic is very important. Anyway, it is important in your quant. DILR also, it is very important. Okay. Now, sum and product of the roots. So if there is an equation like this, ax square plus bx plus c equal to 0. If I ask you, what is the sum of the roots? Sum is given by minus b by a, and product of the roots is given by c by a. All these are basic. I'm just revising them. I'm not getting into how to derive these things. That is not the purpose of today's session. Remember, this is not a theory class. This is just a revision. The purpose of this is practice. So we'll very quickly go on to the problems. Okay. Quadratic equations, nature of roots. So there is something called as a discriminant. What is a discriminant? It is something which tells you about the type of roots or the nature of roots. So if ax square plus bx plus c equal to 0 is your equation, then the discriminant is given by b square minus 4ac. Now, if this is greater than or equal to 0, then They are real roots. If it is less than 0, then the roots are imaginary. Now, if they are real roots, then there are two types. What are the two types? If it is greater than 0, then you call the roots are real and distinct. Distinct means two different roots, different in value. Whereas if the discriminant is equal to 0, then you will say they are both equal roots. For example, x minus 1 whole square equal to 0. This has two roots. You will say 1 and 1. You will say 1 is repeating. How many roots are there? 2. But it is a repeating root. You will not say one root. It will always be two roots. Clear? It's either two roots or it is 0 roots, which means the two roots are imaginary. You cannot have one real and one imaginary in a quadratic equation with real coefficients. Simple? Right. Now, further this can be divided into two parts. If D is a perfect square, then the roots will be called as, what do you call them? Rational roots. And if D is not a perfect square, then you call them as irrational roots. Now let's understand the logic behind it. It's a very simple logic. It all comes from your formula minus b plus or minus root of b square minus 4ac by 2a, which is nothing but minus b plus or minus root of discriminant by 2a. Now if you notice, root of discriminant, if the discriminant is less than 0, this entire thing becomes imaginary because root of a negative number is imaginary. Now if this is greater than 0, then minus b plus or minus some root of some number, some number divided by 2a. So this is a real number. Now if this is 0, then what do you get? Minus b by 2a. Only one root you will get. So basically what does it mean? It is minus b by 2a plus 0 and minus b by 2a minus 0. Right? Plus 0 and minus 0. And therefore these two roots will become equal. If d is non-zero but greater than 0, then you get minus b plus, let's say the root of d. Let's say root of d is some k. So minus b plus k by 2a and minus b minus k by 2a. Right? And this is irrational. Root of d is not a, if it is a perfect square, then your k will be an integer. If it is not a perfect square, k is not an integer. So if it is not an integer and it is an irrational number, so an irrational number will make the entire numerator irrational, which means the entire fraction becomes irrational. If k is a integer, then numerator becomes an integer. Integer by integer is a rational number. That is the logic for this diagram. Clear? Okay, Mohan Bharadwaj says, sir, I'm not good at geometry but consistently getting 28 to 32 marks. How to improve from here on? Mohan Bharadwaj, which basically means you are attempting or you are getting around 12 questions correct. For you now, because you are consistently getting 30 plus, probably for you geometry makes sense. Remember, you're getting 30 plus means you're already attempting 12 to 13 correct and making some 3-4 mistakes. So you're already at that 13 questions attempts point. So two ways. How can you get more marks? One, do less number of mistakes. Don't force yourself on topics. So let's say you are weak in graphs and a graph question comes. Don't do it. Okay. That is one way. But if you don't do that, where will you spend that time? That is where you need geometry now. So for you, in your particular case, you are already getting the maximum out of arithmetic and algebra. So anything more is difficult. So for you, you should go for geometry, provided you are able to do this in 30 minutes. So 10 minutes for 3-4 questions of geometry. Okay, or 8 minutes for 3-4 questions of geometry. If, however, you are not able to finish your arithmetic and algebra in 30-32 minutes, but you're taking the entire 40 minutes, then learning geometry is of no use. Where will you get the time? You don't have time then. So first, you should try to finish your arithmetic and algebra in 30-32 minutes. Is it possible or not? If it is possible, then only geometry will help you. If it is not possible, then don't go for geometry. Rather, become perfect in those mistakes that you're making. So if you are weak in graphs, become better in graphs. If you are weak in quadratic equations, become better in quadratic equations. So that when you attempt 14 questions and get 11 correct and 2 wrongs. So 11 correct is 33, 2 wrongs is minus 2. So you get 31 marks, which is what you mentioned, right? So instead of that, you will get 12 correct and 1 wrong. Straight away, you will get 35 marks. That is the way for you if you are not able to finish and save time for geometry. So unnecessarily preparing geometry is of no use without realizing whether there is enough time for you or not. Clear? Right, Mohan? Let's move on. Right, moving on to logarithms. These are the basic formulae for logarithms. Log of product of a number is basically log a plus or log b plus log c to the same base. Division is written as subtraction. This is an interesting thing. You have log x power y to the base a will be written as y into log x to the base a. And similarly, if I have log x base a to the power of b, so if the power is to the base, then this will become 1 by b log x base a. If there is a power to both the number and the log, so this is log x to the power of y, a to the power of b, this will be written as y by b into log x base a. Right, so both happens. Right, so these are the basic formulae. Then first of all, log. How is log defined? So if a to the power of b equal to c, then the definition of a log is b equal to log c base a. So you bring b down and take c to the top and a will come to the bottom. Cyclical. So it's like a, b, c. A is coming down, b is going here and c will go to the top. Cyclical rotation. So your b will be equal to log, c will go to the top and b will come to the bottom. Okay, this is how you can remember it. And conversion reverse. Clear? This is basically the definition of logarithm. Then you have, this is another important formula. So if I have log of a to the base b and the power is b here. So it's like 2 raised to the power of log 6 base 2. If this base and this base are same, the logarithm is not required. You can directly write the answer as 6. So you can write this directly as a. So if a number is raised to the power of a log to the same base as the number, if this is the base and this is the base, if they two are same, then this logarithm is of no use. You can take it all and you put only a. Okay, that's an interesting thing. And another important formula is if I have log a base b and here it is c, then keeping this constant, I can write it as a power log c base b. So these two can be interchanged without any effect. The base should remain the same. You can see here a and b are getting interchanged. Clear? So these are some of the basic formulae in your logarithms. Now, certain things about progressions. There are certain basic formulae. Arithmetic progression, general term is given by a plus n minus 1 into d. Sum of the n terms is given by the formula n by 2 into 2a plus n minus 1 into d, which is also given. So this can also be written as n by 2 into first term plus last. So this is a plus l. A is the first term, L is the last term. That's the meaning. So it can be written as n by 2 into t1 plus tn, which is also equal to n by 2 into 2a plus n minus 1 into d. So these are the basic formulae for progressions. Again, I'm not getting into the theory of it. If you don't know, it's a problem. It means you are weak in algebra. You are supposed to go and revise, provided you finish arithmetic. If you haven't finished arithmetic, don't focus on algebra, you stick to arithmetic. Guys, remember the order: first arithmetic, become perfect, then algebra, become perfect, then geometry, become perfect, then if time permits, number theory, and then permutation combination. This is the order. Don't go doing everything when the first one is not perfect without the second one being perfect, and so on and so forth. Clear? Alright. So let's move on. So for geometric progression, once again we have general term a r power n minus 1. Sum to n terms is given by Sn is a into 1 minus r power n by 1 minus r, or r power n minus 1 by r minus 1, it's one and the same. Infinite progression, sum to infinite terms is given by a by 1 minus r. This is only possible if r is like this. R is between minus 1 to 1, not even touching minus 1 or plus 1. If it is in between them, only then you can apply the sum to infinite terms formula. Otherwise, you can't apply the formula. Okay. Next is functions and graphs, some basic formulae. Now, if this is given to you, okay, f of xy is f of x into f of y. Now somebody was saying, sir, functions and graphs is difficult for me. If you remember these things, your solutions will become easier. So f of x into y, f of x into y is f of x into f of y, which means your function is of the form x power n. There can be other functions also, but this is a common function that you can use. They will not give the function in this part, will not be given to you in the exam. They will say there is a function which is of the form f of xy is equal to f of x into f of y, and then they'll ask you something. You can solve it by taking this as an example. So this is one of the example functions which will fit into this description. Similarly, if I give you this, f of x plus y is f of x into f of y. If this condition is given to you, then an example function which fits this condition is this. This is f of x is equal to a power kx. It's an example function. There are many functions like this, but to solve the question, you can start using this. Okay? If the question is this form, f of x into y is f of x plus f of y, then the example function is this. Or you can take f of x is 0. But usually this will not give you any answers, so this is a better solution. So the example function for this condition is f of x equal to k times log x. K times log x. Right? So this is of the form when the product can be split as sum of functions. So this, understand this, right? Basically what is it? Log of xy is what? Log x plus log y, which is of the form f of x into y is f of x plus f of y. That's the analogy, right? Then if you have addition getting converted into addition, then it's a simple function of kx. So if you notice, k into x plus y is nothing but k into x plus k into y, which is of the form f of x plus y is f of x plus f of y. So if you remember these example functions for each condition given, your job becomes much more easier. Now next is f of x into f of 1 by x is given as the sum of the product of a number and its inverse function is given as the sum of these two. Then you can remember the function. The example function can be of the form f of x as 1 plus or minus x power n. 1 plus or minus x power n. Both plus or minus will work. So there are two functions that you can use as examples. Is this clear? Right? Okay. So these are some things which are very helpful. Functions and graphs, the questions become very easy if you can remember these example functions. Clear? Let's move on. Okay. Now we are moving on to the practice. Let us see if we can practice about 7-8 questions today before I wind up. So it's already about 7:38. So I have about 22 minutes. Let's see how many how many questions can we solve. The first question coming your way. Here is a question. I'll give you about a minute and a half. Go ahead. 90 seconds is the time for you. Your time starts now. Post your answers and I'll only comment after the 1.5 minute. Your time has started. I'm going to keep track of it. Yes. Any answers, anyone? Guys, any answers? Okay, your 90 seconds are up. Let's go ahead and solve it. Now, the best way to solve this would have been through options. Unfortunately, options did not exist in this question. So, the only way to do this is to go theoretically properly. Now, the question says, Samir has X marbles with him. Samir has X marbles with him. He gave one more than half the number of marbles to his elder brother Puneet. So, Puneet got how many? One more than half. So, half is X by 2. One more than half. So he gave away this many. How much is left then? X minus this. So it is X by 2 minus 1. This much is left. Correct? So after giving away, Samir is left with this. This much is clear? Okay. Now what is Samir doing? And then gave 2 more than 1/3 of the remaining marble. So this is remaining. We need 1/3 being given away. So what is 1/3 of this? X by 2 minus 1 into 1 by 3, 1/3. But 2 more than this. 2 more than this means plus 1. Plus 1. Sorry, plus 2. My bad. Plus 2. So how much is this? Let's simplify this. So this is x minus 1. So x minus 2 by 2 into 3. So it's 6 plus 2. So this is x minus 2 plus 12 by 6. So this is x minus 10 by 6. This is what has been given to, who is that person? Mayank. So what is left then? What is left? He is left with now this minus what he gave away. So 1/3 plus 2 he gave. So what is left? Whatever he gave away, that is remaining, right? So you subtract it, you will get the remaining. So remaining is x by 2 minus 1 minus x minus 10 by 6. So now take the LCM. LCM is 6. 2 3s are, so this is 3x minus 2 3s are, so this is 3 minus x plus 10. So this is 2x plus 7 by 6. 2x plus 7 by 6 is left. Please remember, always do a quick check. If you add these two, will you get x by 2 minus 1? So if you add them two quickly, you will get 3x minus 3 by 6, which is x minus 1 by 2, which is x by 2 minus, I think I made a mistake. This is what? 2x plus 7, right? So 2x plus 1, 3x plus 7 minus 10. This is minus 3 by 6, x minus 1 by 2. Did I make an error somewhere? 16 is correct, Mohan. Very good. But I'm just checking, is this, where did I make an error? Oh yeah, this is 6. Yes. Yeah, this is my mistake. So yeah, I think I got my mistake. So this is 2 3s are, so this is 3x, 1 6 are, so this is minus 6. So minus 6. So this will become 2x plus 4. 2x plus 4 by 6. So this will become how much? X plus 10 by 6, is it? Oh, this is x plus 10. Yes. This is x plus 10. So this is minus. Oh, I think I made a mistake here. Let me just erase this part and write again. Yeah. Thanks for that. I think that was Virendra Singh Tyagi and Mohan Bharadwaj and Gaurav Kumar. Thanks for correcting. This is x plus 10, right? So you take the LCM as 6. So 2 3s are, this becomes 3x. 1 6 are, so minus 6 minus x minus 10. So this will become 2x minus 16 by 6. or x minus 8 by 3. So now, or rather you can keep it as it is, 2x minus 16 by 6. Now if you add these two, are you getting the original? So you will definitely get, if you add these two, you get 3x minus 6 by 6. So this becomes x by 2 minus 1. So yes, your calculation is correct. So this is correct, 2x minus 16 by 6, or you can write this as x minus 8 by 3. Right? Now the question is, this lies between 27 and 127. Now this is interesting. So x minus 8 by 3. So I'm just going to erase this part. X minus 8 by 3. It's lying between 27 and 127. Okay. Now what could be your value of x? How many distinct values of x are possible? So let's multiply throughout by 3. So 27 3s are 21, 3 to 6, 71, 67, 3 to 21. Sorry, 81. Less than or equal to x minus 8, less than or equal to 3 into 127, right? Oh, sorry, x is lying between, my bad. X minus 8 by 3. X is lying between 27 and 127. So basically you're supposed to look at when you subtract 8. So what is x minus 8 then? So 27 minus 8 less than or equal to x minus 8 less than or equal to 127 minus 8. So you are converting this x into x minus 8 by 3. So what is 27 minus 8? 19. 19 greater than or equal to x minus 8 less than or equal to 127, 119. Now between basically means, yes, this equal to sign should not be there. Equal to sign should not be there. Guys, remember the word between means not inclusive. Is that clear? Okay, right. That is the English understanding of it. Now you want by 3, so divide by 3, by 3 and by 3. So this is 6 point something less than x minus 8 by 3 less than 3 3s are 9, 10 11 29, 3 8s are 3 9s are 27. So 39 point something. So 7 to 39. This is your answer. 7 to 39. How many distinct values of x are possible? Is this all there is to it? 3 3s are 9, 3 4s are 12, 3 6s are 18. Yeah, I think that's all there is to it. Oh, there's a problem. Yeah, not everything will be possible. Yes. Why is everything not possible in this? Because this has to be an integral value. This has to be an integral value. So let's take an example. So if you start with 27 less than or equal to x less than or equal to 127, you want, okay, by the way, please keep in mind, what is x minus 8 by 3? This is the number of chocolates left out. Chocolates, or what is that? Marbles, number of marbles. So x minus 8 by 3 should be an integer, correct? X minus 8 by 3 should be an integer. So you should only choose those values of x. When you do this, will give you an integer. So if you take, for example, this equal to is not there, by the way. So if you say x is 28, if you take x as 28, then 28 minus 8 is 20. 20 by 3 is not an integer. So 20 is not, so 28 is not possible. Look at 29. If you take x as 29, 29 minus 8, 29 minus 8 is how much? 21. Now 21 by 3, so 29 is possible. Why? Because 29 minus 8 is 21, 21 by 3 is 7, which is an integer. It is possible. Look at 30 then. If you look at 30, 30 minus 8 is 22, 22 by 3, not possible. 31, again you'll see not possible. 32, 32, what is 32? 32 minus 8. 32 minus 8 will be, how much is that? Sorry, 24. Yes, this is 24. So 24. So this is 24 by 3, which is possible. So you can see that from 29 onwards, so the series will be 29, 32. So the gap here is how much? 3. So the next gap should be 3. So 35. You can check for 35. 35 minus 8. How much is 35 minus 8? Anyone quickly? 35 minus 8? Yes, 27. So 27 by 3 is 9. So this is the series. How many terms are there till you reach 127? So you will basically have to count how many such terms are there till 127 starting from 29. Right? You will have 16 terms in total. So the way to look at it is use the progression. So you have Tn less than 127. So what is your Tn formula here? This is a series. So 29 plus n minus 1 into d. D is 3 less than 127. You will see that n will turn out to be 16. So 16 terms will be there. Correct? Okay, let's move on to the next question. Let's go ahead. I'll give you once again 90 seconds. It's a difficult question, not an easy one for sure. So 90 seconds, next question coming your way. Okay, let's go ahead and take a look at it. X represents a series in which all the terms are consecutive integers. All the terms are consecutive integers. Okay. Okay, I just got a chart. Okay, it's just a correction. Fine. That's already been done. Right. So where was I? Yes. So let's say the first term is a. Now we are talking about consecutive integers, which means the next term should be a plus 1. Consecutive integers only grow, and a plus 2 and so on. So the sum, let's say there are n terms. Let's say there are n terms. So the nth term, whatever the term number is, will be a plus n minus 1 into 1, which is a plus n minus 1. Great. Now what is the sum to n terms? It is 100. The sum of all the terms is 100. So 100 is equal to the sum of n terms, which is given by n by 2 into 2a plus n minus 1. D is 1. So 100 equal to n by 2 into 2a plus, okay, it's like as it is. So you can just open this, or you can just write it like this, n minus 1. So 200 is equal to 2an plus n square minus 1. Now find the difference between the maximum and minimum possible number of terms of x. So you want the number of terms n to be the maximum possible and n to be the minimum possible. 4 consecutive terms will give you a total of 100. What could they be? First of all, is it possible with 2 terms? Because they are talking about x is greater than 1, correct? X is greater than 1. Now this approach, mathematically if you're going, you can see it's getting into an unnecessary quadratic equations. If you're solving it in the exam, this is where you're supposed to stop. Say, hey, what am I doing here? I'm getting a quadratic equation in n. I'm talking about minima of this and maxima of this. Even if I want to find minima maxima, a is unknown. So if I use the formula of minima maxima that I know, I'm going to get another variable and another equation in which there is a variable. probably this is not the right approach. Then what is the right approach? What is the best way going forward? Then start thinking about it. Let me first take the simplest case. If I want minimum number of terms, consecutive terms adding up to 100, can I get two terms? Let's see. What are the two terms? 45 and 46 crossing 100, 44 and 45 less than 100. So you cannot get exactly 100 with two terms. So two terms is not possible. Is it possible with three terms? Three terms means approximately should be in the 30s. So let's look at it. 32, 33, 34. Is it adding up to 100? 4 plus 3, 7, 7 plus 2, 9. So it is only 99. What if I take 33, 34, 35? It will go beyond 100. Not happening. So three terms also is not enough. Similarly, think, can I go for four terms? If I want to go for four terms, it should be in the 20s. So 23, 24, 25, 26. Is it possible? Now remember, the total is 6 plus 5, 11, 11 plus 4, 15, 15 plus 3, 18. So 18 plus 80 is 98. Not possible. If I increase it, 24, 25, 26, 27. Is this possible? Is it going to work for me? Let's see. 7 plus 6. 7 plus 6 is how much? 12. Sorry, 13. 13 plus 5 is 18. 18 plus 4, 22. So I'm crossing my requirement. So 4 terms also is not possible. Is it possible with 5 terms? If it is 5 terms, it should be in the 20s, right? Somewhere in the 20s. Not even more than 20, somewhere less than 20. Sorry, in the 10s. Okay. So let's look at it. 16, 17, 18, 19, 20. This will not be 100. Okay, so you will take 17, 18, 19, 20, 21. So this is 20. This should be 20, 20. Okay, this is also not possible. 18, 19, 20, 21, 22. Now, this seems possible. Look at it. This is 19 plus 21, 40. 18 plus 22, 40 and 20. Total is 100. So with 5 terms, till 5 you checked everything. It was not possible. Till 5 you checked everything. It was not possible. At 5 terms you got. So the minimum terms required is 5. Now the question is, what is the maximum number of terms required? What is the maximum number of terms required? Now, when you start thinking about maximum number of terms, many students think, okay, I'll start with 1 plus 2 plus 3. I'll go till I get a total of 100. Please remember, this will give you may give you a total of 100, but that is not good enough. Why? I want to maximize the number of terms, and we are talking about integers. Remember, integers go on the negative side also. Integers go on the negative side also. So can I start with negative side and go to very long positive side, such that negatives and positives get cancelled, and the remaining I'll get total as 100. If it is possible, how can I take? That is the idea that should have struck you. If that idea strikes you, you'll get your answer. So basically, for example, if I want the total as 0, what will I do? Minus 1, 0 and 1. 1 and 1 gets cancelled. 3 consecutive terms, my total is 0. If I want more terms as 0, I can take minus 2, minus 1, 0, 1 and 2. Again, they'll get cancelled. I'll get the answer as 0. So I can keep adding both sides and they'll all get cancelled. But if I continue this side, somewhere this remaining total should give me 100. So how many terms can I take such that whatever I have here will get cancelled here, but the remaining should be adding up to 100. The remaining should be adding up to 100. What are those numbers which when added will give me 100? Obviously, I can't go beyond 100. Obviously, I can't go beyond 100. And I can't go till 99. So let's say if I take minus 99, minus 98 and so on, 0, 1, 2 up to 98, 99. If I do this, now all of these got cancelled and I'm left with 100. So what is the sum of this series? What is the sum of this series? This series total is starting from minus 99 to plus 100. All of these terms got cancelled. I am left only with 100. So the total is 100. This is the longest I can take. This is the longest chain that I can take. So totally how many terms are there? So you're starting from minus 99 to plus 100. Can somebody quickly tell me how many terms are there? 1 to 100 is 100. Minus 1 to 99 is 99 plus 0. So 100. So 100 plus 100, 200. So 200 terms I have taken. Okay, 200 terms I have taken, that is a maximum, and the minimum is 5. So 200 minus 5 is 195. So you get 195 terms. It's a beautiful question where logic and maths have been combined. Right? If you try to do it brute force, like the way I started, then you will not get the answer very easily. Is this clear? Is the idea clear? So such questions are beautiful. You have to get the... So now what happens? Sometimes some of you are good in maths. You start off saying that, okay, let me form a quadratic equation. You should not be carried away just because you're good in maths. Stop. You wrote 3 steps. You start realizing, understand what is happening. It is not going the way you want it to go. So you're supposed to stop there. Think, am I doing it right? No, this is not the right way to solve. Think of a different way. You get it in the exam, good. If you don't get it in the exam, don't continue that stupid question. Leave and move on. Clear? Let's move on. Okay, this is a question. Find the number of integral coordinates lying in the region represented by inequations. I'll actually give you a different question, guys. I want you to solve this question. Okay, try this. It's a nice series-based question. I think we are already at 8-2. So I'll be stopping it probably after this. We don't have too much of time today, but hopefully in a subsequent class I'll be taking up more questions. Probably I'll ask my team to have a second session with you where theory and the formula are already done. I'll ask them to only solve the questions now. So next session when we have, only the questions will be there in algebra, whatever is left out for today. Okay, so I will end the session with this particular question. Please go ahead and solve. Anyone? So all such questions of fractional forms normally, usually should be solved by trying to split the denominator into 2 numbers which form a pattern. For example, if you look at 21, 21 is 3 into 7. 77 is 7 into 11. 165 is 11 into 15. And 285 is 15 into 19. Now, what is the pattern here? 3 into 7, this is a difference of 4. 7 into 11, so 7 is repeating, and again the difference of 4. 11 into 15, 11 is repeating, difference of 4. 15 into 19, 15 is repeating, a difference of 4. So the pattern is very clear. The denominator is forming a pattern of multiplication where one number is getting repeated and the difference between the 2 numbers is a constant. So whenever you have a fraction of the form 1 by x into x plus k, when you have a denominator in this form, you can always write this as 1 by k into 1 by x minus 1 by x plus k. You can always split it. So those of you who knows partial fractions will know this. If you did not know, did not have that concept in maths, don't worry, it is not for your cat. Just remember this. Whenever you have a denominator in this format, you can always split it as 1 by k into 1 by x minus 1 by x plus k, which means if this is of the form 3 and 7, the k here is 4. So your x is 3 and your k is 4. That's the pattern. So you can write this 1 by 21 is 1 by 3 into 7 as 1 by 4 times 1 by 3 minus 1 by 7. Now if you want, simplify this and see. So denominator is 7 3s are 21. 7 minus 3, 1 by 4. 4 and 4 gets cancelled, you are left with 21. So you can always split it into two fractions, one positive, one negative. That is the beauty of this question. A lot of questions are framed on this logic, which means you can convert this entire question as, this can be converted as 1 by 3 minus 1 by 7, 1 by 4 plus 1 by 4 times 1 by 7 minus 1 by 11 plus 1 by 4 times 1 by 11 minus 1 by 15, and so on up to 19 terms. Now remember, they are talking about 19 terms. First term starting with 3, next term is 11. So what is your series? 3, 7, 11, 15 and so on. So what will be the 19th term starting? So you want T19. What is T19? A plus n minus 1, 18 into D. D is 4. So how much is this? 18 into 4, 40. It was a 32. 40 plus 32 is 72. 72 plus 3 is 75. So this will be 1 by 4, 1 by 75 minus 1 by 79. Now take 1 by 4 common. This will be 1 by 3 minus 1 by 7 plus 1 by 7 minus 1 by 11 plus 1 by 11 minus 1 by 15 and so on, plus 1 by 75 minus 1 by 79. If you notice, all these terms will get cancelled except the last and the first. All terms are getting cancelled. So what are you left with? 1 by 4 times of 1 by 3 minus 1 by 79. Take the LCM. What is 79 into 3? 7, 9, 3 is 27. So this is, in fact, the denominator is given here, 237. Okay. So 237, so 79 minus 3 into 1 by 4. This is 76 by 273 into 1 by 4. 4 ones are 4, 4 nines are 36. So 19 by 237, option C. Right? So my friends, this is how you solve. So remember this. All those of you who say series type of questions, functions and graphs, they are difficult. They are difficult because you don't remember the patterns. The only way, the cheat code for these topics is to remember these patterns. There are limited number of patterns. They can't create new patterns again and again. Okay, there are very famous limited number of patterns. Remember those. You will become an awesome student for algebra in these topics. Right? With that, my friends, I bring today's session to a close. I hope you have got a kind of revision on this topic, and most importantly, you have started understanding how to approach these questions. I will ask my team to set up another class on algebra where we take a lot of these questions that are left out for today. We didn't get a chance to solve too many questions, so I will have definitely another session coming your way. Thank you and all the best for your CAT preparation.